just kind of go into what we are. Mintbase is basically the Amazon of digital assets on a blockchain, providing the best tools for the new virtual economy. So you basically come on board, you create your tickets, your VR assets, gaming, photography, all sorts of things. Ticketing has been a big item for us. So how does all this work? So basically, the big difference is the creator is the owner of a token. They come on board, they deploy their own smart contract, and a customer can buy that asset directly from them. And after 12 seconds, the asset moves from the creator to the customer. The funds get moved over to the creator. And now we have this beautiful interoperable asset that crypto voxels and OpenSea and exchanges can all interact with. I'm going to just kind of jump into a little show of what it is. So I'm going to hook into Rinkeby. Rinkeby is a test network. Imagine it's just a big world where anyone can come on and basically interact with your application with fake ether. So what I'm going to do is hop in here. And so here's my sort of dashboard. We can see all the NFTs that were created. If we want to go ahead and come in here and edit, we can see all these different bits of NFTs. If we wanted to create our own whole new smart contract, we can come in here and deploy it. That would then populate into this item. And as soon as we come in here, we can basically mint new tokens or old tokens, also mint fresh tokens from scratch. So we can declare whether it's art, we can add multiple files, and we can declare when these items are actually available. And so with that in mind, as soon as we upload the image and the content, everything goes to this thing called Arweave. So I'm gonna actually dive into all of what makes this interesting. So let's go into open. Okay, here we are. So we have over 725 deployed smart contracts with 70,000 transactions and over 18,000 users. So how were we able to do all this with just me as the developer and designer? Let's see. We were able to do it with this tech stack. So on the left side, we can see all of that is the traditional. So we're using Next.js as our server-side rendering engine, React, Stripe. We also accept credit and debit cards via the same on-ramp as how Lyft drivers go through. We are using Google Firebase and and Google Functions. Mainly, a lot of that is just for experimentation and doing things really quickly. So a lot of how we're redeeming tickets at conferences is basically run by those systems. Or let's say our email engine with SendGrid is fired off when those things get interacted through that pub sub model. More on the decentralized side on the right, we've got Arweave, which is how we're storing all of our files, OpenZeppelin, which is what is the lower stack of our tokens, and a whole bunch of others. I won't go too deep into all the rest. The main two ones that we're really going to dive into are the graph and Arweave. So basically, the graph is how we keep in sync with the blockchain, and Arweave is where we're storing the actual data of that NFT. And we'll go into why that matters. But I'm going to kind of pull out of the depths of that and kind of explain what an NFT is and why those are quite interesting in today's world. So let's go into, so interoperability is a big thing. So we essentially have this new system where the token itself is the API. Anyone can use that token and the smart contract to interact with that. So we don't have to open up our own APIs that restrict people to do certain things. And why that's neat is we can go into beautiful worlds like, let's say, crypto voxels. This is our headquarters, where a lot of we've put up some pieces of work from people that have minted on our platform in our space. And what's quite neat about this space is that I have to be the token owner to actually build on this system. We can actually see a nice, beautiful little Unitize setup. Also, if you haven't noticed, you actually built, a lot of you have actually owned this Unitize token that was minted on Mintbase, which enabled you to actually vote. So what we're really pushing for is the process of being able to not only have a token as a collectible, but to be able to have those tokens do a lot more than sit in your wallet. We want it to enable you to vote, to be able to get you into co-working spaces, to get you into physical conferences, to send a pizza to your door. We want it to do a lot more. And this interoperable aspect is, here's crypto voxels. If they wanted to, they could import the store. So let's say we go into our NFTs, it would load my NFTs, and I can actually pop my NFTs in here directly without Mintbase ever having to actually open and expose those endpoints. Hopefully that makes sense, but yeah, it's a big mental leap for a lot of people. All right, so leaving the virtual world and coming back into this land. If you're not familiar with MetaMask, this is just one of the wallets that I use. If I actually come in here and we wanted to do a fresh mint, actually let's just see the whole process work from the beginning. So let's say we are full node, which is the co-working space that I work at, in. If I wanted to come in here and do a fresh mint, we can upload an image. Let's go 600 by 600. Maybe we want to give away a day at Dacha, which is a very good Russian restaurant. We're actually going to load these files up to Arweave, the block weave, which is another blockchain that interacts. That we basically put this image URL into the smart contract. We'll just say this is a free lunch. We're going to just say, describe what this does. We'll mint 7 of these things. We'll say it's a product. We'll list a price. We can also add a whole bunch of other pieces, but let's go ahead and mint. So now we're interacting with Ethereum. So as soon as we interact with Ethereum, this is the wallet that we're using. My platform doesn't keep any of your wallet information. We just signal to your wallet and say, hey, I'd like to mint this token. So then what we're basically doing is now, without me touching anything, we're basically constantly pinging the graph to say, hey, once Ethereum has minted that token, I want you to update my interface and actually show that token. So we basically interacted with 2 blockchains. We have Ethereum, which there's our token that we just minted. It works. We can mint more of these things if we want. But that's a whole lot of technology working together. And I'll actually dive a little bit deeper into why that's interesting. So if we come into, let's go over here. All right, so hopefully you guys are kind of grasping the idea of interoperability. It's, yeah, you can interact with Twitter APIs, but this is a whole new world where if Mintbase goes away, then the token will still exist as long as Arweave and Ethereum exist. And so what you get is you come onto our platform and you deploy your own store. And when you deploy your own store and we say smart contract, this is basically what you get. You get all these beautiful functions on the Ethereum blockchain. So the really hard part about building a blockchain company right now is we're seeing kind of a new world is being able to basically allow your application to work with all these different wallets. So we want the asset to not just live on Mintbase. Anybody can create a website and then have an image show up, right? That's not that big of a innovation. The big innovation is, okay, now that asset can be bought, delivered, sold, transferred, burned, and do all these different really interesting interactions on whatever wallet you want, because all these wallets have different security models. They have different features, and you get to choose which wallet you want. This is kind of the big, wow, that's blockchain starting to work. And so we're very much very pro being able to allow you to figure out what wallets you want. I actually created this thing with sound on it, but when you log in, you can have Fortmatic, which is Web 2.0, Coinbase Wallet Connect. Wallet Connect allows you to connect with Argent and Trust. Coinbase Wallet, obviously the Coinbase Wallet, and so on. So back into the tech stack. So if you've noticed, there's a thing called 3box, which is a really fascinating application, because when everyone talks about identity, if we actually go into Mintbase and I go onto mainnet, so my application doesn't start screaming at me, because that's a good thing. So once that loads up, you'll notice more Unitize and San Francisco Blockchain Week tickets you can also grab that are available now. If I come into our markets, we use this company called 3box. So you'll notice, you'll see our logo, and a few, that means the user or the creator or the person who minted hasn't created a 3box account. So we can actually even come into our Unitize store, which I think is 2 layers deep. And again, each one of these are their own unique deployed smart contracts by our users. You can see here's the Unitize smart contract. We can actually click this and see that they have their own token. This is the user's address that created this token, and we can see some information. So if I actually go into 3box.io and / the address, there we go. So we're pulling information. This user is this user because they verified their Twitter account and so on. So going back into the actual market. So if we come back here and we can hop in here, you can see all the different items that you can actually grab. The Unitize voting app, that's all nice and sold out, so sorry. But what's really fascinating is, look at this thing. Here's the actual contract hash. So if we click that, we can go into this thing called Etherscan. Now this is another idea behind interoperability. So being able to see all of the information within the blockchain all right here. We can see 276 unique addresses are actually holding these tokens, and we can see each one of the addresses that are holding that token. And what's also neat is here's all of these beautiful functions that you can get on the smart contract. Supply is 601. If we want to see token by index, let's say 3, we can get the token ID by index is 31. So that's quite interesting. And if you want, you can actually update items within the smart contract directly here. And coming back to the interoperability aspect, if you run your own virtual reality website, then you can also connect to this smart contract and do the transfer and all these other functions, as long as you are the actual owner of that. So big difference to how we're building on today. So going back to this. So also Truffle, great system to be able to publish the items. But again, we're just going to talk about the graph and Arweave. So first things first, when we minted that token, you saw a few things happening. One, every time we uploaded a file, it went to Arweave, and 2, notifying us, the application, when that mint has been minted. So just looking at the graph, let's start down here at the bottom left on the Mintbase site. Basically, you're the user, you're interacting, you're minting, you connect whatever wallet you want. Again, we interact with all sorts of wallets, lots of wallets. Once you interact with that wallet and you say, I want to mint 10 of these, we notify your wallet either MetaMask, Trust, or whatever that is that you need to do that. You confirm it. That thing goes on to the blockchain. Once that gets confirmed, then it goes, the graph is constantly listening for this update to happen. It then pushes that data up to IPFS. And then once that's been updated, then our site is constantly listening for the graph to update. So once it says, Nate, you've just minted 15 of these things, then we're going to update that thing. We cannot, as a company, change the graph. Only your interactions with Ethereum can change the graph. So this opens up a whole new door with interoperability, allowing OpenSea, CryptoVoxels, and Decentraland, and all these other groups to have a choice. They can either directly ping Ethereum, again, that smart contract directly to move, to check how many or whatever. But if they want to hit something really quick, like say, who's the owner of this NFT? Are they the owner of the ticket of this NFT? Then CryptoVoxels can ping our graph directly and just check to see if they're the owner of that. If they are, they can do a quick signature and then they're done. So really, really fascinating change. Instead of us listening directly to Ethereum, it turns into a nightmare. You end up just doing millions of loops that is very inefficient. So the graph kind of aggregates all of that stuff together. So here we're going to start talking about Arweave for a second. So basically you come in as the minter. So you create your market, your store. You can create as many stores as you want on Mintbase. Let's say you're an ad agency and you want to mint one for Nike, a Nike campaign, and you don't want any of the information crossing between, let's say, Samsung. So you can create a whole different market or smart contract for Samsung. So let's say we are in, so this is all on Ethereum. So then you mint all your NFTs, it's all in Ethereum. And then once that mint is created, all of the files, because Ethereum is just definitely not the place to be storing files. It just costs too much money and it'll fill up the blocks way too fast because everybody in the world is basically copying all of the state, and that just gets bloated, and that's a whole other topic that we'll go into. On Arweave, the Arweave block weave, which is designed for storage, we're basically holding all of that information. So let's say we minted 4 different batches of tokens. Each one token can actually have several different file types on that token. So we can mint MP3s, MP4s, music, legal documents that says you are the licensed owner of X, Y, and Z, and here's the piece of art that comes with it. What's really neat is we got to actually have Camilla Russo mint one item onto our system where she just launched her book, The Infinite Machine. And if we come into it, she actually, so here's her market. Boom, boom, boom. So once that loads, the Infinite Machine, she actually gave a, you have the main image. This is one NFT. You have the main image, you have the text that comes with it, and then you have the title of it. And we actually have a sound file. So all of this is all within that one NFT. And so the authorization of that token can do a lot more on top of that. So if we actually want to check, here is the unique ID for this metadata. We can actually go into arweave.net / we put in that that ETH or that ID. I'm surprised that actually. So then we get this metadata, and the metadata is set in stone. I can't change this. You can't change it. No one in the world can change this information. It's set in stone. We also have the image. If we go over here on the arweave.net / that ID, and we have the animation URL, which is the actual sound that goes with it. So we have immutability. We have a timestamp of when it was created. We have it, and it's verified by several different gateways. That's quite massive. Big difference from storing something on an S3 bucket where any of my employees can go in and change it whenever they want. It would never stand up in court. So here we go. Let's go into So now we're living in this whole new world where here's this NFT, here's Mintbase. We have Ethereum, we have Arweave, and we have the graph all kind of working together. If Mintbase ever decides to disappear, or if who knows what, then basically that's fine. Your files will keep living on as long as Arweave and Ethereum still continue. And all these other different decentralized applications can also ping the graph for that latest information. So this is kind of the next iteration. Next.js, just to go in the traditional realm, it was a big change for us. Really happy we did that. It's switching from a single page to a server-side render. The biggest reason why we did that is because we have a very visual website. So the only way to get dynamic social cards was to switch to this. And now we're going to be constantly optimizing to push and make Mintbase much faster over time. That's basically the big grand scheme of it. We can actually come in. Let's see. So if you want, you can just kind of come over to Mintbase. You can just kind of skim through what people are creating. DJs are starting to come on board, photographers, and all sorts of other groups. Yeah, I think that's it. Thanks a lot for tuning in, and give us a try. Again, you could try us on rinkeby.mintbase.io to test it on that, or you just go to mintbase.io and that'll be on mainnet. And definitely, if you want to follow along, you can go into our Mintbase Twitter. That's easy to find us. We're on Telegram too if you run into problems. And yeah, let me know if you have any issues. Thanks. Bye.
Thanks for the overview, Nate. It's great to see how easy it is to produce your own NFTs for your needs. For those of you that are just tuning in now, if you have any questions during the workshops, please feel free to ask them in chat. Our speakers will answer them accordingly. Now for our next talk, we're happy to have David Awad, developer evangelist at R3, give a Corda developer bootcamp. He will walk you through specifically how to build a blockchain application in just 1 hour on Corda. David, the stage is all yours.
Hey there, my name is Peter Lee. I'm a developer evangelist at R3. It's our pleasure to welcome you to the San Francisco Blockchain Week. I'll be running a virtual booth here with my colleague David Awad, along with the R3 Venture Development team. We'll be happy to answer all of your questions, so feel free to reach us by clicking our names in the virtual booth page and send us an invite. Now, Without further ado, I will pass it to David, who will run a Corda developer workshop for you. Pass to you, David.
Hey, everybody. It's good to have you here. Thank you so much for joining. So we are going to talk to you guys a little bit about building off of Corda. And to start, we have a whole lot of references for you. So I'd love it if you guys could take a look at these. You could first find people like me and Peter and the other developer evangelists here at R3 on our public Slack channel. You can also find the docs. We've also recently launched a new training site you can find at training.corda.net. You can find our GitHub repository. Corda is open source, of course, so you can find that online at github.com/Corda. If you have any questions about this talk or any other talks we'll be running this month or in the past on our YouTube channel, feel free to send us an email to devrel@r3.com. Lastly, you can find us on Twitter and send us all kinds of fun screenshots and blockchain ideas at Corda Blockchain and at Inside R3 with the usual fun hashtags. So we look forward to hearing from you. So all of that being said, we will start with the agenda. Today, it is going to be a quick recap of the intro to Corda that we did at our last event, if you were there. Then we'll talk a little bit about the key concepts relating to Corda apps. We'll write one together ourselves, and then we'll talk about how to actually run it. It should be a good session, and it should be useful for everyone here, just to kind of build a good understanding of how developers can go to proofs of concept using Corda. So we'll start with the basics, right? To recap from our Corda intro from last time, Corda is a really powerful open source blockchain solution. It gives you strong identity features. It gives you performance and scalability. You have interoperability. You have an open source tool and really easy extensible features to run a network with other people. You have the usual blockchain features of consensus as well as privacy. And you can customize it to get a lot of different levels of these different features to, suit your particular use case, which is quite nice. So just to kind of cover the basics here, right? Corda is a permissioned network. It communicates on a peer-to-peer basis and on a need-to-know basis. So let's say you are Titan Technology Partners and someone else is Colorado River Authority. Each of you has your keys, you have your addresses, and you have the ability to communicate with each other and represent digital assets that you're interested in tracking together, knowing with confidence that the blockchain is not going to be manipulated by any of the parties, even if you distrust them. And of course, in any typical Corda network, you have the notary pool operating alongside you to validate the transactions as you go. And we'll talk more about how that works as we get into the flow framework. So just to kind of put this into context, try to keep in mind that our network here between us, Titan Technology, Base, Transcorp, and Colorado River Authority is a subset of the many other Corda nodes across the internet that are working to track all kinds of different assets. You can find out different parties that are using this by looking into the Corda Network Foundation and finding out which other parties out there are really using Corda to track their assets and run notaries to mediate their transactions between each other. Pretty nice. So that being said, let's start with the basics. So we keep using this phrase Corda app. We're going to have to define it at some point. So Corda app, long story short, is a Corda decentralized application. So long story short, that means a computer application that runs on a distributed computing system. Not surprising. It is also sometimes referred to as smart contracts. That's another way to kind of refer to what we're able to enable with this, right? So Corda apps are literal binary jars that are stored inside of Corda nodes. Any node can carry multiple Corda apps, and those Corda apps that you write are what enable particular features on those Corda nodes. So we write our Corda apps, and then we copy those jars onto Corda nodes in order for them to have the features that we want them to do, whether that is tracking loans or mortgages or using blockchains for voting or what have you. You can write your Corda apps yourself and then deploy them by copying them over onto the Corda nodes that you have running in your secure network with the other parties you want to work with. So let's jump into this idea of the blockchain at kind of a literal level and see what we can build here. So When we say blockchains, we sort of literally mean data that can be anything you want to represent digitally, anything that you wish to store in Corda. And those states or those things are updated, their representations are updated via transactions that act as the chains between the states of things that we call blocks. For the purposes of this discussion, this is the intuition you should try to use when thinking about this. One of the nice things about having in our model of a blockchain within Corda is that you can also backtrace really easily. All of the transactions exist, and all of these states and previous versions of states also exist. So we even have some nice notary validation features where you can take a transaction and trace the entire history of the chain leading up to that state to ensure its validity, which is quite nice. So it's worth mentioning here, just to keep this in mind, Corda does adopt the unspent transaction output model. So data is never actually deleted from the blockchain or the database. Hence, Corda holds the sort of immutable nature of a distributed ledger technology system. So just to kind of finish this recap and bring it back together, when you're building a distributed app or a Corda app, Corda provides you some really simple abstractions, right? You have a pretty low learning curve. We support Java and Kotlin and other JVM compatible languages if you're curious. We abstract away the complexity of updating a distributed ledger technology, and we also have some great development tooling. We have a network bootstrapper. We have some really nice tools for Docker on Corda. We have a Node Explorer that you can take a look at on our blog. And we also have a VS Code extension if you're interested in trying something directly. And lastly, we have some pretty cool developer tools that enable some interesting feature sets, right? So the Corda Settler, I recommend taking a look into, the token SDK, and the account library, which can help you build some more advanced and scalable Corda apps. So just to bring us into the actual live coding that we're going to do today, assuming I haven't talked enough, we're going to build a Corda app to kind of showcase the issuance of a token. And we'll talk more about what that means. But long story short, the files we need to implement are tokenstate.java, tokencontract.java, and tokenflowinitiator.java. Don't worry if you don't know what any of those mean yet. We're going to break down these different abstractions really quickly before we actually just get right down to building them together. So hopefully we won't lose any of you, and I'll make sure to show you every piece of the process, straight from cloning the repository to running the flows ourselves and seeing the hashes of our transactions. So these are the components of a Corda. There are states, there are contracts, and flows. So states are any object in Corda, right? These are cars, these are loans, these are votes, these are mortgages, etc., etc. Any object that is fungible that you want to represent digitally is a state in Corda terminology that you can represent. Corda makes this very easy for you. States get consumed, they get updated, they get stored, they get created, they get destroyed, etc. Separately, contracts you can think of as the tool to verify what you can and cannot do with a state. For example, you can create a car, but you cannot do other actions with a car, right? Maybe if you sell a car to someone, that car must have a license plate of 6 characters, let's say, if you live in New Jersey. Just as a random example, so that 6-character license plate rule might be something you would embed into a contract. So if someone tries to sell the transaction of selling a car to someone else, the contract can verify that the car is valid by ensuring that its license plate has 6 characters. So contracts are the tool or the abstraction we use to validate the operations we can do with states. Lastly is the flows. So when we talk about issuing a token or creating a state, a flow is the tool through which we can trigger updates to the ledger or transaction. So for example, a flow to perform the sale of an object, a flow to perform the issuance of a token, which we're going to do today, and flows to do all kinds of other things like adjusting a loan, making a payment on it, for example, or changing the interest rate, etc. So these are the three kind of ideas: the things, what we can do with those things, and then triggering the actual process of performing those things themselves. Putting all of these together, you have a pretty robust set of tooling that you can use to build a wide variety of different use cases on top of Corda. And that's sort of where the power comes in. So I promise we're going to show you some code in a second. This is the last piece of information I want to give you guys, which is the token state itself. The first thing we're going to build, the simplest abstraction for us, hopefully, which is, again, states, the objects we want to represent digitally. They only exist in the participating nodes of the specific transactions. If I sell a car to you, that state exists between the two of us. We are the only ones with knowledge of it. And in terms of the code, our state is going to live in tokenstate.java. So that's where we're going to start. Let me close out my PowerPoint here. And I'd like everyone to go online to github.com/corda/bootcamp-corda. And I'll give you guys a few seconds to find this link, clone it onto your local machines, and I'll do the same. Peter, if you could drop the link to that in the YouTube chat, that would be great. So I'm going to open up my terminal over here, and I'm just going to clone this repo real quick. So I'm just going to go onto my desktop. There we go. And I'm going to clone the Bootcamp Board app. There we go. And I'm going to put it in a folder called 11-6 Bootcamp. There we go. So I will clone that. It's appeared on my repository. So I'm going to go then look inside. You should be on the v4 branch. Just make sure you're on the latest version of that. And you will want to make sure you've just got the right revision. So I'll just run a quick git rev parse head, which will show me the latest version, the latest commit. This is one I actually made pretty recently because we made it a little easier for people to use this when looking at this stuff again yesterday. So assuming everyone's got this, you should have the v4 branch, latest revision, and I will open up my editor just to grab this and import it into IntelliJ. So IntelliJ is going to be my editor of choice. You are also more than welcome to use the Corda online IDE. I believe that is at ide.corda.net. I'll actually double check that real quick. Yep. You can try any of those online tools and find links to them. Hopefully Peter is dropping them for you in the chat as far as the online IDE is concerned. So if you're using IntelliJ with us, you'll get to see all the specifics. So for us, we cloned this onto the desktop, so we're just going to open the project in IntelliJ. We're not going to import it because that blows away some of the project configuration. So I'm going to hit open here and just jump onto my desktop. 11.6. I'm going to hit open there. And we are loading the 11-6-Bootcamp project. So you'll see here that IntelliJ is going to ask me if I want to import this Gradle project. I'm going to do so real quick. There we are. We're going to do a few other quick project-specific configurations before we get started with actually coding. First, looks like we have our first error, which is good. Now this one is going to be complaining because I've got to do a few things for my own editor. If you're on Mac, you may run into some issues with Java 1.8. So just make sure to click this little elephant on the right side and double check that your project's Gradle JVM is set to 1.8. Hit OK. Rebuild your project. I'm going to do one other thing, which is go into the project structure settings. You can find this by hitting Command semicolon or going into File, Project Structure, and specify the SDK. In this case, I'm going to go for Java 1.8 and specify the project language level of Java 8. So again, that's the project SDK 1.8 and project language level, and set that to 8 as well. So I'm going to hit Apply and OK. Gradle is probably going to need me to rebuild, which is fine by me. Go. Let's see. All right. Configure successful. Green check marks. Looks good. So I'll give you guys a few minutes or a few seconds just to make sure that is all set up. Remember, that's just to go into the settings here. You can find these settings by hitting the Gradle box over there, hit the wrench, and then you will see this Gradle JVM version. And again, that is project structure for the Java 1.8 settings I was looking at before. If you've imported successfully, you should see a few things in here, a few modules that we're going to be working out of. So I want to just kind of outline those for you now. So inside of the Bootcamp Corda app, we have source, main, Java, Bootcamp, and we have 4 files: token contract, token flow initiator, token issue flow responder, which we will talk about when we start looking at flows, token state, and of course, contract tests, flow tests, and state tests. So for us to start off, we're going to look at state tests, and we're going to look at the token state file itself. Hopefully you guys have got this open. And so since we're good test-driven developers here at R3, we are going to talk a little bit about what these files, or what these tests actually do. So we have this idea of a token that we want to represent visually, right? And we talked a little bit about, let me pull this back over. We talked a little bit about how we want to have the idea of a token state that implements the Corda contract state abstraction. And we want to outline the issuer, the owner, and the amount. Looks like I need to zoom in to make this a little easier. All right. I don't know if I can zoom in. Let's see if I can get that. Yeah, hopefully you guys can see this. It might be might be a little tricky to get this to zoom in, so hopefully that's not too big of a problem. All right. So, like I was describing, we want to build a token state that implements the Corda contract state interface. We will outline a few properties: the party issuer, party owner, and the amount itself. So let's get right down to it. So inside of here, we have some tests that are just going to verify some of the assumptions we're describing, right? We have, we want to make sure that our token state has the correct issuer, owner, amount params, and those kinds of things. So we'll start by creating a token state in our tests. Then we'll assert that Alice is the issuer, that Bob is the owner, and that the amount is 1 because we've instantiated that here. We do a similar thing with the participants, and we make sure that the token state implements the contract state, like we were describing. Of course, all of this is going to be red because we have not implemented any of it. So here we are inside of the token state. Again, this file is inside of Bootcamp, source, main, Java, Bootcamp, token state. So there's a few things we're going to do here. I'm just going to run over to a set of notes I have over here. So to start, we want to point out the fact that this is going to belong to the token contract. Every state has an associated token contract class. We're going to be implementing that in a little bit. So our state tests won't pass just yet. So just be aware that our token state, again, is going to implement the Corda contract state abstraction. And then within here, we're going to create a few member variables. We're going to create some parties. We're going to start with the issuer. Then we're going to have the owner. Then we're going to have the amount for the token. Then we are going to have a list of type abstract party. And we are going to call that participants. Whoops, there we go. So we created our instance variables, and we will probably continue to get complaints for a little bit longer as we implement this. So let's just start by creating the token state class itself. So public token state, party issuer, party owner, amount. Go. Looks good. So I'm going to do this dot issuer equals issuer. This dot owner, just the basics. This dot amount equals amount. There's a really nice keyboard shortcut to do this, and unfortunately I did not remember it. So we're just gonna have to go the hard way here. So we'll create a new array list to store our participants, and then we're going to add the actual owner and issuer into this array list of participants. And this will come in handy in the future when we start looking at some other pieces of this process. So for now, just make sure to add the owner and issuer to the participants list. And it doesn't matter too much the order you add these in, but I will go issuer first, then owner second. That's pretty much everything for this method. Then we're just going to add some getters. Simple enough. And I'm going to do the same for the owner. There we go. I'm going to do one more for the amount.
Hey David, really quick. So when you get a chance, do you mind to zoom in a little bit? So from the preference, and then we can see the editors, and then font.
Thank you. Yeah, let me go. Let me try 16, see how that looks. Does that work for people?
Thank you.
Is this clear? Cool, thanks. Appreciate it. All right. So, as I was saying, so we want to implement that last getter, public int get amount, and then we will return amount. We actually don't need this dot. That looks a little more verbose than we want. All right. Lastly, then we're going to add one more method, which is just to return that list of participants we created before. So we're going to go at override. At not no. Public list. Abstract party. Get participants. And of course, this is just going to return participants. Here we go. Hopefully your class looks something like this, if everyone can see this. I'll give you guys a few seconds just to make sure you've got all that down. I know it's a lot. So again, the big talking points here are that we provide a contract state class which you can implement the methods of. And so we have a few kind of tools that provides you, and that's why that interface defines this method here for getting the participants, which we track in most Corda in most Corda state classes, and that's what this notion of owner and amount being the participants is all about. So whenever you're writing a Corda state, make sure that you implement the contract state abstraction, and make sure you specify what contract is actually associated with the state that you're writing. Now we can't run these state tests just yet, as we have to implement contracts. But hopefully, after we've run contracts, our tests will all run right out of the box. Hopefully. I don't know of any demo that's ever worked on the first try, but we'll see what we can do. So, assuming everyone's got this, I'm just going to move on and jump back into the slides for a little bit here. Talk a little more about what the contract is doing relative to the states or objects themselves. Hopefully we can see this. All right. So again, we talked about those contract states being, those regular states being the object, and the contract states are the rules that outline what makes transactions valid or invalid. So to make this a little more clear, right? Every transaction or ledger update is done via a contract verifying the validity of it. So in the ideal case, you have some input state. Let's say it is a loan, and that input state of the loan has some amount on it that is due, and that previous version of the loan, when a payment is made, must be updated. And so a transaction happens that consumes that existing state and then performs a transaction on it, consuming the input state and producing a desired output state, right? According to certain contract rules. So those rules obviously need to be followed during a transaction. So try to keep that in mind when thinking about this, right? A transaction is only valid if all of the contract rules have been properly fulfilled. So if our contract says everything is good and we have these beautiful green check marks, then we get a ledger update that is recorded to all of the parties involved. And of course, on the other side of this, if one of the rules does not pass, the ledger update is rejected. And that's pretty much everything to keep in mind. One other note, in terms of input states, there is not always an input state. In our case, we are creating something or issuing a new object. And so the token state we are creating will not consume an input state. We're just doing this for simplicity as far as showing our proof of concept here. But it's worth keeping in mind, of course, that the majority of use cases probably do consume an input state. And we have plenty of samples online on how you can do that. You can also contact us after to get some specific links if you have specific questions. So this is an issuance transaction that we're about to write. And so our contract code is going to look something like this. Now, in this case, the token contract Java class implements the contract abstraction that we also provide for you. So we're going to implement a verify method that takes a ledger transaction and verifies a few important properties of it. One, that there's no input states, like we were describing here. Two, that there's only one output state, right? We are only issuing a single state, and that output should be of type token state. The issuer should be a required signer for the transaction to be valid. The owner must also be a required signer, and we'll make sure that the amount field is positive because you can't issue negative money, just as a good kind of rule of thumb and a nice rule to add on to that. So let me dip on the slides real quick. So I'm going to pull up to start with the contract test, just to kind of outline. We talked a lot about 6 very specific conditions here. So there's actually a lot of different ways that this can go, that this can be tested, right? There's a lot of different moving parts to this contract validity. So we have a whole lot of state tests that I recommend taking a look at inside of here to see how we how you might want to think about testing this. For example, the intuitive first test case require that the contract has 0 inputs, to the transaction. Require that the contract has 1 output, require that the contract has 1 command, etc., etc. So definitely take a look at the contract test. We will run these in a little bit to make sure that they work the way we expect, but I just wanted to give you guys a good sense of how thoroughly you can test and validate the transactions that go through these fungible assets that you want to represent. So jumping out onto the other side, looking at token contract. Token contract.java is the next file we're going to look at, also inside of main Java Bootcamp. So you'll see here we have a bit of a few method skeletons here that are worth talking about. So the first thing worth mentioning is that, again, token contract implements the contract abstraction. So that's the first thing to be aware of, right? This contract abstraction needs to exist. And if you have this little red blurb inside of your editor when you're trying to add this, just remember that sometimes IntelliJ needs a few extra imports. You can hit Alt-Enter to add it. So in my case, I will do so. It should be included right in the imports up there. So the token contract that we are going to write implements the Corda contract abstraction. We're going to leave this ID intact, and we're going to override the method transaction. Go. we're going to override that verify method. And we can see here how it takes a ledger transaction, and it also throws illegal argument exception. Now, before we start writing this, I want to speak a little bit to the commands interface that we have down here. So contract commands, you can sort of think of as the actions themselves that we can do with those objects. And so you'll see here that we have kind of a skeleton class called issue, which makes sense. Now, issue here is purely a convention. We could call this whatever we wanted. We are defining our own semantics for how we want to name our commands and what those commands actually mean within the contract code itself. So in our case, we are using the word issue, but that is purely a semantic distinction for our simplicity. So you can create other commands such as sell, or sell to state, sell to government, sell to private citizen, etc. And you can create those different commands that have different types of verification that you would apply. So in our case, right, we are just going to retrieve that command and put a conditional statement around what kind of command this transaction is trying to perform, so that we can write the correct verification for that transaction. Hopefully all that makes sense. Feel free to drop, again, questions in the chat for Peter if you need anything on that. And feel free to let him know if he needs to stop me for anything else. All right, so I'm going to start just by getting a command with parties object of type token contract.command. Whoops. And we're just going to call this command. This is actually the commands that we are receiving in the transaction itself. And we'll talk more about how the command gets specified when we look at the flows. So we're going to get the commands from the transaction and then retrieve them here and use them as a variable. Token contract commands class. So we're going to create a command with parties object. And again, that is require single command tx.getCommands, token contract.commands, class being the other argument, and of course the semicolon. So let's start by creating some lists of contract states. We're going to create two lists. These are the inputs and the outputs to the transaction. So I will create those right here. List contract state inputs equals tx get input states. Go. I'm going to do an alt enter just to get that imported as well. Then we'll do the same thing for outputs. And of course, if we're going to get output states, we need to change this method as well. Cool. So now we've got the inputs and outputs to our transaction. That sounds like it's going to help out. So now we want to write validations that are specific to the kind of command we're interested in. So in this case, we're going to go and look if the value of the command is an instance of token contract dot commands issue. And this again is just the issue that we've defined down here. So we have our if block. We're going to do one other thing. If we currently have only defined one command, we've only defined the issue command. So if we get a command to this contract that is not issued, we're just going to throw an exception for now. We're going to throw a new illegal argument exception that just says, hey, unrecognized, whoops. We're just going to throw an exception that says, hey, unrecognized. There we go. Awesome. So now we're prepared to actually write all of the verifications that we were talking about. We've specified within this transaction of our contract code of this command type, we want to validate 6 rules, right? We want to validate just looking for these 6 rules here, these 6 things. I'll drop them in here. Oops. There we go. We want to validate these 6 things. That there's no inputs, that there's one output. The output is a token state. The issuer is a required signer, The owner must also be a required signer, and that the owner's amount field is positive. So let's start with the easiest one, ensuring that there are no inputs to the transaction. So we are going to add a function here that is a require that, and it will do most of our stuff inside of here. So we will start with require that rec. We'll use a quick bit of function magic here for those of you who like that. Fix my horrible indentation here. There we go. We're going to require that the transaction must have no input states. And of course, then we have to pass the actual conditional for this to be valid. And that will be, in this case, inputs dot is empty, right? Which makes sense. There's no inputs to the transaction. On the other side of it, we want to make sure that the transaction has a single output state. So we're going to do output dot size 1. Great. Then lastly, we are going to, or then next, we're going to make sure the output is a token state. Transaction output must be a token state. So we're going to specify that with another conditional. This one's also pretty simple. In order to get the actual, in order to get the actual token state or the state from this transaction itself, we're going to call outputs.getZero. And then we will make sure that this is an instance of token state. There we go. Cool. So now we're going to do one other thing. We're actually going to stuff that into a variable so we can use it for some other things. So we're going to call token state. I'm going to create a token state that we can use here. We're just going to call it output equals. We're going to cast this. We're going to cast this outputs.getZero to type token state. So now we have the same token state that we were using before. No difference there. And with this output, we can validate some of the specific aspects of it. So for example, we want to make sure the next thing on our list that an issuer is a required signer. So let's do that. The reason I'm adding these descriptions to the requirements is actually because when you run your contract, these will be the error messages that get produced if contract verification fails for one reason or another, which can be nice when you're trying to troubleshoot or audit your transactions after the fact. So the issuer must be a required signer, so I'm going to pass a conditional here to get that required signer and make sure that its owning key is legitimate. So we're going to call commands.getSigner.contains, and we're going to make sure here that the contained in the list of signers is the owning key of the issuer. So I'm going to call output.getOwner.getOwningKey. And we'll see here that we are validating that the correct key is within that list. And then we'll do the same thing, not for the issuer, but for the owner, who also must be a required signer, which makes sense. Whoops, made a small mistake here. I called output.getIssuer.getOwningKey. And here I'm calling getOwner. Sweet. All right, there we go. So then on the other side, we are going to add our last condition, which is going to be to make sure not just that the issuer and the owner are required signers, but that the amount field is positive. And so we can actually do this one relatively easily. I'm going to add one more conditional here, which is that the amount must be. Like that, we will go and call. In this case, we already have the object, so we can just use that getter we called before. And we will specify that this is greater than 0. And that looks like it should be it, with the exception of the fact that, of course, this function has to return something. In this case, if it returns null successfully, then the verification has passed. So it would seem, if we're lucky, we've written everything we need so that these tests work on the first time. You can feel free to paste your bet in the chat whether the tests will work or not, depending on how confident you are in my ability to write code. Frankly, I give it about a 50-50 if this works. So I'm going to rebuild the Gradle project real quick, and I'm going to open back up the contract tests, and we'll see if they work. So I'm just going to hit this nice little run button. It should run the entire suite of unit tests we have here, and then we will see. So everyone cross your fingers. Yes, this is another detail worth mentioning. So if you're running this in IntelliJ, you may run into one other little painful thing, which is just the module class path can get a little bit bungled. So specify that JRE and also specify the class path. In this case, it's, I believe we can just set it to 11-6 bootcamp, and we shouldn't have any problems there. So I think it's test. Let's see how that works. All right, running. Now these tests might take a little while. There's our first check mark. That's good stuff. Check, check, check. I'm blown away. So this is nice because it verifies a few things, not just that our contracts are valid, that our state tests are also valid. We have some warnings here just from some Corda compatibility things, but you won't have to worry about that too much. Next thing I want to try running just to make myself feel good is the state tests. So feel free to take a look at those. Same story. We're just going to hit run state tests over here in IntelliJ. We'll have the same situation with the modules. So we will run the tests, and the JRE should still be set to 1.8. Apply that. Run these. See if it works. Great. And it passed instantly. This is good stuff. So the last piece to talk about is, of course, the flows, and we will get into that in a minute. Feel free to open flow test if you want to prepare. But for right now, I'm going to jump back into the slides and talk a little bit more about what's happening when we really run flows. So now that we've written our contract, we've written the rules that outline what we can do with the objects we want to represent and what makes those commands or what makes those things we can do valid as outlined by the contract. We now want to think about how we can actually trigger this whole process. How can we trigger transactions? How can we include our own custom business logic into this process so that we can trigger the contract updates to the state when we want to? And this is where flows really come in. So take a minute to just kind of absorb this diagram and think about what a flow is. A flow, we like to say it executes the business logic, but really a flow is a way for you to trigger transaction updates. So flows have a few things going on. They consist of two classes, an initiator and a responder. The idea here is that if I'm going to trigger a transaction with you, the two of us, obviously, if we're going to have a conversation, one of us has to start it. One of us has to say, hey, I'd like to sell you something, or I am going to sell you something, sign this contract, right? There's this idea that one party initiates a transaction and other parties respond. Now, this is not a one-to-one relationship. There can be one initiator and many responders, etc. There's more on that in the documentation if you are interested. But for our purposes, imagine a party A and a party B enter the notary pool, like we talked about earlier, where A proposes an update of some kind. A says, hey, I'd like to sell you this car, or I'd like to issue this token, this loan, this amount of cash, what have you. So I'm going to propose this update. I'm going to run my own contract code against my own update for this Corda app that I have installed on my node, my Corda node. You have the same Corda app on your Corda node. So when I propose and validate and sign my own update, I will send that to you, the other party, who will receive it, and the responding flow will be what retrieves this information and be triggered when my initiating flow communicates with you for a signature. So my initiating flow will do these three things, Then I will communicate with my Corda node will communicate with your Corda node, running the same Corda code, and respond to that flow. It will check the update, and by check here, we mean the contract code, right? Our second signature here will come next. If the contract update is valid, we will then sign it ourselves as party B. Then party B will inform party A of its signature to the contract, at which point party A will go back to the notaries and ask the notaries to sign the update as well. If the notaries sign the update and it is considered valid, these can also run the contract code that is configurable depending on use case. Then the update can be recorded for party A, and then party A will inform party B, and party B will have the recorded update as well. And so what you are seeing in this timeline is the life cycle of a flow. And what you are seeing as well is the life cycle from the perspective of A, the A being the initiating flow, and B being the responding flow. So this kind of makes sense, right? I go to you, I want to perform a ledger update, so I have to do a little more of the paperwork to make sure it happens. But you have to obviously sign it before we can go to a notary to ensure that to have it validated, and then both of us update our checkbooks is kind of the idea here. So hopefully all that makes sense. If you have questions, feel free to drop them in the chat as we go. So we're going to implement a very similar scheme to this. I'll jump out of the slides for a second and jump back into the flow tests, because as always, we're good test-driven developers, so we want to actually make sure that we're using tests. Now, it may not surprise you, there's a good chunk of tests here, because there's a pretty important series of steps that we want to make sure we can perform correctly. So I'll start by uncommenting all these tests. Do that right here. All right, so we've got our tests, and just to kind of keep up the theme here, the tests here are similar to what we've been describing earlier. How is the transaction constructed? Is it constructed by the correct notary? Are the correct amounts being created on the other side? We see that here, asserting that the amounts are equal to 99, and that the output states that there's one output state, etc. We have some other things about the correct contracts and things like that. So definitely take some time to look over these unit tests if you get a chance. So let's go back and open the token flow initiator. And before we start writing this, I want to do a little bit of lip service to the token flow, the token issue flow responder as well. We're not going to implement this ourselves. Most of the time, you can use Corda subflows to accomplish the job of responding in most use cases. So just to outline the framework here, inside of token flow initiator, the first thing that we actually specify is not just the initiator, but who is going to respond to this. Am I an initiating flow? So that's what's happening here underneath these imports. We specify that this is an initiating flow class, and that it is startable by RPC, and that this token flow initiator extends the flow logic class in Java, or sorry, the flow logic interface. And so we define some other things that the flow needs in order to run, which is the owner and the amounts. The issuer, it is assumed here that the issuer is going to be the node that runs this. If I'm issuing a token to you, then I don't need to know myself. I only need to know who I am issuing to. And so when we see this token flow initiator class, we see that inside of the token issue flow responder, that this class is explicitly identified as the initiating flow. And so on the other nodes, when I run my flow and tell other people that I'm initiating a token issue flow, those guys know how to respond to that because of this code that we were talking about. And right now, all we really need to do here is we can actually just use subflows, right? We can use the subflow provided to by Corda to receive a finality flow from the quote unquote other side and submit the signed transaction ID. And pretty much this does a lot of the heavy lifting for us. And the last thing I want to mention about this is that when we have this signed transaction, we can actually implement our own custom checks on the responder side here as well. it is not, the contract is not the only place for you to enforce certain conditions. You have a lot of different places you can do them. So it's not just that any random person who proposes to a signed contract update can do whatever they want. You can ensure certain boundaries on that as well. So that's pretty much everything I wanted to say on the token issue flow responder. So feel free to close that or keep it open if you like, but most of what we're going to do is in here. So we leave a couple of to-dos inside of the Bootcamp Corda app, inside of this file. To do 1, 3, and 2 here, I just want to specify that we've actually done this in the correct order, even though the numbers are in a different order. It all depends on the way different people at R3 like to present this. So in our case, we've implemented token state, which is our step 1, and we've also implemented token contract, which is our step 2, which is how we end up at step 3, which is to build our token issuance transaction update. So just to outline what's happening in this code a little bit more clearly. When I run a flow, if I'm going to issue currency to somebody else, again, just to reiterate, I am not the owner, I am the issuer issuing this currency to somebody else. So I need to know who that person is in order for, and I also need to know how much the amount is that I'm issuing to them. This is why in our token flow initiator, this is all that the flow needs to know in order for it to satisfy its own abstraction. We create something called a progress tracker, and this essentially will show you command line visibility within the Corda shell of the progress of a flow as it is running. And you'll see what we're talking about a little bit later. But this is a very nice little tool that you can use to observe your flows as they're running and get some sense of which steps within the flows they're actually at. So now let's talk about the meat of this class and where you'll probably spend most of your time if you're writing Corda apps, which is inside of the call method. So as usual, we're overriding the interface here. This is also suspendable. And when we say suspendable here, what we mean is that flows obviously are mediating the connection between you and somebody else. So we need to make sure that these can be suspended. There is a great blog post by one of my colleagues named Sneha on the Flow Hospital that I highly recommend taking a look at after this. So when we call this signed transaction, what we are doing is this is the code you can think of as actually running the flow. And so the first thing that happens is we choose our notary. We actually go and we ask the Corda Service Hub to give us a reference to the network map cache, and we get the notary identities, and we just grab one. We grab the first one we find, and then we get our own identity so we can use it as we are the issuer. And so then the next thing we can do is actually create the token state class so that we can start really building something more meaningful here. So the token state, you can probably intuit, is going to be created using these private member variables that we created before. When the flow was run, we passed in the owner and the amount, and we passed these in from the command line when we actually trigger the flow. So this token state is just going to use those, right? So we are going to say new token state issuer owner transaction, whoops, amount, getting these terms overloaded here. So we've created our token state. Now we need to build a transaction. So unsurprisingly, we have a transaction builder abstraction. So we will actually take the notary and pass that to the transaction builder to get this process started. So we have the notary that we're going to use. The next thing that we're going to do is actually verify our transaction. Actually, there's one other thing a few other things I need to do before we can get to transaction builder.verify. Sorry about that, guys. So before I can actually verify this transaction, we need to specify what kind of transaction is it, right? So that is where the command data comes in. Whoops. There we go. So we're going to specify our command data, and this is going to be the issue that we were talking about before. So you'll see here, we're going to actually go and specify the token contract.commands.issue, which makes sense. We are creating an issue transaction, so we have to specify this command. The next thing we're going to do is we're going to add the command to the transaction. So we're going to call transaction builder.add command. We're going to add the command data. And we're going to add the issuer's owning key. Then we're going to add the owner's owning key. And just for being thorough here, this next piece of the transaction builder is going to be adding the output state. Which makes sense, right? We have some tests around this. So we want to make sure that our output state is only one token state, a modified one. And we're going to pass the token contract.id. All right, so we've done a lot of grinding, built out the details of our transaction. We know what type of transaction it is. And we have the actual details of the states that we want to be exchanged here. So now we can go and call transaction builder.verify using the service hub to get Corda to get our nodes to do this, right? So then after that, we have our flow session. We're going to initiate a flow from the perspective of the owner. We create a signed transaction. And then not only do we sign it ourselves, but we make sure that we have others sign it as well. In this case, the others signing it are obviously the other parties. So once the transaction is fully notarized, it will be recorded automatically by the platform. So you might notice, like I was describing earlier, you might expect there to be a lot more code around these other ideas we were talking about, right? This idea of going to the other node, waiting for them to respond, dealing with network latency, peer-to-peer communication, network bandwidth problems, etc. So Corda handles all of this for you, which is really nice. And so that's what these subflows are kind of doing for you. And I highly recommend kind of digging into the docs to see the specifics of what these do. Fortunately, most of the time, you probably won't need to worry about these much because they're pretty sweet abstractions. So these subflows do things like, as you can see here, collecting signatures, or the finality flow, which you'll see a lot, which, for lack of a better name, right, it finalizes the transaction for you. Once you've got the fully signed transaction, you can basically take this and run with it. So let's run our flow tests. Hopefully this all works. We will see what happens, that's for sure. So here we are back in flow tests. You should be able to just hit the run button, and I'm going to click run flow tests right here out of IntelliJ. We will probably get those module problems, yep. So I'm going to specify here the Java version 1.8, and we're going to specify the test module within the Bootcamp. I'm going to hit apply, and then I'm going to hit run. And let's see what happens. The flow tests may take a little bit longer because we create a mock network with party nodes that are intended to sort of replicate all of the aspects of the network, which can be really nice. Most of the time, just as a pro tip, if you're going to be working on Cord apps, I recommend actually running your tests and writing very thorough tests with various different scenarios and running them from here, just because it can be kind of a pain to open the Corda, to rebuild your node configurations every time, open the Corda shell and then run the flow directly. So this can be a much nicer way to do it. This looks good. Wow, can't believe it worked. Awesome, okay. So now this is kind of the last piece of the puzzle. I've shown you a whole lot of editors. I've shown you a whole lot of abstractions. I now want to show you guys how to actually run this flow. Peter gave me some good advice earlier. I'm going to zoom this in. Hopefully this is clear enough for you guys. So again, I'm just inside of the Bootcamp directory. I'm going to clear this out, and I'm going to start by running the, I'm going to call the Gradle wrapper. If you do an ls-la in here, you will see this Gradle W executable. Some people say Gradle U. So I'm going to start by running Gradle W/deploy nodes. And to understand a little bit more about what this is before I run it, this actually, I will run this task. And what this is going to do is it's going to build our actual node configuration. It's going to handle a lot of the kind of lower level tasks of figuring out how the nodes are going to talk to each other, creating some of the certificates and a lot of information on the actual party that exists. And so all of this is defined inside of this top level build.gradle. So you'll see here, I'm actually running the deploy node task. deploy nodes task, it does a few things, right? It checks the Java version. It outlines these are the different nodes that we want to create, right? So leave that in the background for a second. So it outlines 3 different parties, right? Parties A, B, and C, as well as the notary. It also outlines passwords, passwords for the user accounts on the Corda shells of each of these nodes. This is really nice because obviously when you're testing, you can do a lot of experimentation with these kinds of things. Change up passwords, change up the permissions of which nodes can talk to each other so that you can get a really good idea of how you can expect your Corda app to perform in production when running on a real Corda node. We also have some other information in the build.gradle worth taking a look at for where the sources of all this software comes from. And of course, the Corda release versions and some of the other plugins that we use that are also available online. You can kind of see where those come from. Probably, though, I suspect the majority of your work will be around this kind of node configuration tooling. So to come back to the terminal here, it looks like our build was successful, equally shocking. So I'm going to take this and just do a quick, just for my own machine, I'm just going to make sure I don't have any other Java processes running. And then I'm going to run the ./build/nodes/run nodes. So what this is going to do is it is actually an executable that has been created for us by the cord form task that we just ran, that being this one from the deploy nodes Gradle task. So this is going to actually run our nodes, and it should run them correctly on your native local machine, whether you're on Mac, Windows, etc. So let's give it a try. And if this works correctly, we should see my terminal over here pop up with a few different processes. And let me see if I can zoom this in just to make it a little clearer for people. Looks good. All right. How's that look for people? I'm hoping Peter will just let me know if this is hard to see, but if it is, just feel free to post in the chat. Really quickly. Go. All right. There's a lot of text on the screen right now. Let me just do this just to make it super clear what's happening. So we have a few nodes here. We have party C, the notary. I'll just start with party C and run it towards party B. This is the typical Corda shell. You'll see a few things that were outlined in that config file: the peer-to-peer messaging address, the RPC connection, localhost, and these actually come from that task as well. You'll see here that the RPC settings are outlined, the ports and things for the different nodes. So party A, party B, 1007, 1008. In 2010, 2011. That's what's kind of happening here. So I'll just take party up. Okay, well, party C is already minimized. Then I'll start with party B. And what I'm going to do is actually just run the flow start bootcamp token flow initiator. Actually, before I even do that, just to show you guys what this kind of looks like, I'm going to run a quick flow list. This shows all of the flows that this Corda node has available to it. And we'll see actually that there is the bootcamp.token issue flow initiator that we were talking about. And so one other nice thing to notice here is if I go and I run flow start bootcamp, let me just copy it. So if I go and I run flow start bootcamp token flow initiator, you might be wondering what's the format, or maybe you'll forget because there's a lot of different paradigms submitting arguments. You'll actually get a nice little hand guide here for running the actual flow. So in this case, like we defined within the flow, this owner party amount int actually comes from inside the token flow initiator, inside of the class definition. This party owner int where that comes from. So as party B, from the perspective of party B, I will specify that the owner, the person I'm going to issue this to, is going to be party C, and the amount is going to be 33, let's say. What the heck? Very well, parsing flow. Oh, here I am talking about how nice the user experience is, and I messed it up. Owner party C amounts 33. Hopefully that gets us there. So here we see the progress tracker actually running, and we didn't add too many things to it, but we see the basics, which is it starts, it requests a signature by a notary service, requests, it validates the response, it broadcasts the transaction to all the participants, and it's done. And the flow is completed with the result, signed transaction, and it shows you the ID, which is quite nice. So this is kind of the whole sort of life cycle of building a Corda app, getting yourself from an idea, from this abstraction of a thing that exists in your mind, to an article that you can track digitally using a blockchain that is totally immutable. It's a really powerful little thing, and it's a great set of tooling that you have available to you. One thing that you may want to find inside of the actual README for this project, you will see all of the abstractions we talked about, as well as some other tools to run this flow and other ones, and get some nice things out of that. There's one last thing I want to show you, which is a vault query. Now, we didn't talk much about this notion of the vault, so I want to just talk to it briefly. So here within Party C, right, we talked about this idea that the two of us manage states internally. And one thing about that is those facts or shared states or things are stored inside of a vault. So we ran the issuance from Party B. And one thing I just want to show you guys is how you can actually run a vault query, meaning how can I be sure that when this flow was run, that Party C really has it on the other side the way we expect. So we can actually do that. We can run something called a vault query, where again, a vault is just what we refer to as the private store on a particular Corda node of the facts relevant to that particular party. So in this case, I can go and do this. I can run a Corda query or a vault query to the vault. And you'll see this also in the bottom of the README. So what I'm doing is I'm specifying that I want to run a vault query, and I'm specifying the contract state type, and I'm calling it I'm passing that bootcamp.token state, which is our state from earlier. And there we go. So we see that the issuer is Party B, that the owner is Party C, and the amount is 33. Hey! So there you go. We also outline the type of the contract. We have the notary that particularly signed it. We have some different aspects of the transaction that is really thorough, and it's quite nice. So I highly recommend trying it for yourself, going through this process. Hopefully, all of this kind of made sense. It's a really robust system that does a lot for you, and we love to kind of talk to people about the different ways you can use Corda to enforce smart contracts between you and other businesses or other parties that are mutually distrusting, which is quite powerful. So I believe that is everything that I have for you. So thank you very much. Check us out on LinkedIn, on Twitter, on the various social medias. We're always happy to talk to people, and you can find us in lots of different ways, and we're always looking for new ways to talk to people. So I want to thank you for taking the time to do this, and appreciate it. Yeah.
Thank you, David, for taking the time to prepare such a great bootcamp. For those of you that are just joining us now, if you have any questions during the workshops, please feel free to ask them in chat. Our speakers will answer them accordingly. Now for our next talk, we're happy to have Fett, CTO at Tellor, give a workshop on building on Tellor. In this workshop, Nick will walk you through how to build your oracle on top of Tellor in just 3 simple lines on Solidity. Nick, the floor is yours.
Hey guys, I'm Nick Fett from Tellor, and I'm here to present you guys today a little bit on how to use Tellor. So for those of you guys that don't know, Tellor is a decentralized oracle built on Ethereum. A decentralized oracle, basically what we do is we allow you to get pricing information into your dApps. I know a lot of you might think like, well, do I even need an oracle in a project or for my company? And it's usually the first question that you want to ask yourself, because it's actually how I got into the issue. So before I was doing Tellor, we were actually building a derivatives protocol. So it was allowing you to bet on the price of Bitcoin or the price of US stocks or the price of gold. And whenever you're doing that, what happens is you run headfirst into the problem of, well, okay, well, who gets to say what the price of Bitcoin or the price of the S&P 500 or the price of gold is? And this is where you actually need an oracle. So if you know, in Ethereum smart contracts, they can't read APIs. They can't go talk to the internet. So usually somebody would need to put in the price of Bitcoin or gold. And this is a centralized point of failure. So in the case of the derivatives or a lot of financial products, usually the company is just the one who's sitting there, and then they'll enter in the price. And the problem with this is that now if that company wants to say that the price of Bitcoin is $1 million, or if it's zero, they can really cause you to lose a whole lot of money. And I've given several talks in the past. You can feel free to go look those up, just on how much of DeFi is currently relying on a lot of these centralized feeds. And it's really a big problem in the space. So if you are building a project, make sure that you really think about the oracle problem through and through, and how you're getting this information on chain. Tellor, the way that Tellor works, we have a network of miners. So similar to Ethereum or Bitcoin, where they're solving some sort of meaningless proof of work computation, and they get to say what the valid block of transactions are. Tellor's miners, they solve some meaningless proof of work computation and then get to say what the price of a given asset is, say Bitcoin or gold. And that's how Tellor works. And this allows us to completely remove that central party. So without getting too much into the details of how it works, I'll post plenty of links up there. I'm just going to share with you guys today how to implement Tellor into your smart contracts. Obviously, if you guys have any sort of questions, feel free to use the chat. Myself and my team will just be kind of answering them for you as you place them in there. So thanks for listening, and I will get started. So first, I'll share our screen. So I'm going to do a dangerous thing here, and we're going to try and do a software demo. Just live. I'm going to code up a whole new repo, and we'll see if it works out. So first, we'll go into we'll create a repository. So we're just going to make a new. We'll call it Unitize, and CD into there, and then we'll do a truffle init. So truffle init is how you can start a project with Ethereum's truffle. And then, so we're good there. And then the first thing we're going to do, since it'll probably take a while, we're going to install using Tellor. So you're just going to do npm install using Tellor. Now, what I'm doing here, is I'm going through our documentation. So if you go to read the docs/Tellor, you can click on our latest here. And what you'll see, if you go integrate Tellor into your smart contracts, this is exactly what I'm just going to be walking through. So you can go follow along here if you don't want to listen to me talk. But it should be nice and easy, and we'll go through it here. So the first thing, basically, what are we going to build is the main question. And I think we should just, if for what most oracles are, we're just going to actually build, let's pull in a value and see whether or not it's greater than 100, just for a super simple thing. And for this, we actually have a whole sample repo up for pulling these things. So we'll go copy some code and then we'll walk through it. So we'll come here, this is just my IDE. And then what we'll do is we'll go into our Unitize folder. All right, so now that we're in our Unitize folder, we'll make a new contract. And so we don't have to do a whole lot of typing, because I know typing is like the worst thing to watch in code demos. We're just going to cut and paste the sample using Tellor, and then I'll walk you guys through it. So we're going to save it as, we'll call it the unitize.sol. All right, and then contract unitize.sol. So if you guys are semi-familiar with Ethereum smart contracts, this should look pretty standard. But the way that it works, so you got your pragma, and then what we're going to be doing is we're going to be importing the using Tellor package. So using Tellor, all that using Tellor is it exposes some of the getters in the Tellor contract, namely get data before and get current value. So it allows you to read Tellor values. So whenever you're starting the contract, here's your constructor, you have to pass it two things. You have to pass it a Tellor ID and the Tellor address. The Tellor address, as you all should know, is the contract address of Tellor on the given network. You have to know where you're querying. Shouldn't be too hard to figure out. And then the Tellor ID, this is the ID that corresponds to what asset you're querying. So ID 1 is ETH US dollar, ID 2 is Bitcoin US dollar. If you go back to the read the docs, you can go look, and there's a whole list of, I think we have 51 assets up currently that are supported, and you can go query all of those. So you have to know which specific one that you'll be querying, and you put that in. And then after you do that and you're running, then you have access to the using Tellor functions. Get current value, so it will look up the current value of Tellor ID. And it's going to, both of these return three things. Did get, this is a Boolean, so true or false if it did get it. The current value should be pretty easy. And then the timestamp. So how old the current value is. So, you know, if you're using a derivatives contract, you might want to make sure that the value that Tellor has is within a day old, or even within 10 minutes old. Just will all sort of depend on the application that you're building. And then get data before. This one's a little bit more complex, but the reason that you would want to do this is the way that Tellor works is whenever people place the information on chain, there's some time there where there isn't really a finality to Tellor values. And what this means is that it can be disputed. So let's say somebody places on chain and says the price of Bitcoin is $8 million. What will happen probably very quickly in the Tellor system is that somebody will come and they'll say, hey, that's wrong. They flag it, and that miner will actually get slashed. So the miners have to put up a bond that they can get slashed if they lie. And that value will get taken off chain. And so you would just wait for the next Bitcoin value to come up, which would likely be correct. So if you wanted this, how long you want to wait. So whenever you're running get data before, if you wait a whole day, it's had a lot longer for people to look at it and validate it in the network versus getting just a current value. Obviously, if you're doing it manually, like we're going to be doing here, you could just look at the value yourself and then go run it, since all the Tellor values are also on chain. Anyway, those are the two things that are available. And let's write here. What we're going to do is we're going to write a function, or we're going to check values. And this is going to be an external function. And what we're going to do is we're going to check whether or not we're going to update the values. And make this one public, ones are external. And then what we're going to do is if current value is greater than 100. I'm going to return true. So external returns Boolean. And then we'll do else return false. Okay, so for readability. And this is going to be a really simple contract. Obviously, what you would do if you had a financial contract, say you could pull a start price, have it wait the day, pull an end price, and you can have some funds move. Or you can have a lending protocol that uses Tellor to figure out whether or not you're fully collateralized. There's a lot of different things you can do with just the ability to query a price without needing a central party to put it in. Happy to go into those use cases anytime. Anyway, so save this, and now we will compile it. Okay. Man. We're just going to comment this out for now. And then we're not using it. There we go. We're good to go. Anyway, now we're going to move on. So this is really easy so far. Hopefully all of you guys are with me. Oh, I forgot we'll go back to the code real quick because this one came up on our last hackathon whenever people they were like, what is this in the constructor function? So using Tellor, so contract is using Tellor. There's just a little bit of solidity for you guys. This actually inherits all of using Tellor. So this would be like pasting the using Tellor contract underneath this one. But it has a constructor argument as well. And it takes Tellor address. So you have this constructor, which you have here, but you need to pass this Tellor address into using Tellor. So that's all of it's doing. This is accessing the constructor arguments for using Tellor. That's good. The next piece is that you're going to need to do though, whenever you're starting up your favorite thing, you're going to need to run migrations, and you're also going to need to test these things. So let's do those. Whenever we're running, back to our things. Here are, quick, as we just walk through before I forget, the main net address and the Rinkeby address are up here. So if you guys are wondering what Tellor addresses should I use, just look in the documentation. And then the migrations file, I actually have sample migrations file written for you guys. So you guys don't have to actually write anything. And we'll go here. What you want to do is just cut and paste it because you can have multiple migration files. So you'll come here. Okay, new one, save it as to Tellor migration, Tellor migration.js, JavaScript file. Okay. Okay, and then whenever you're migrating, if you're actually going to Rinkeby or mainnet, what you'll want to do is just use this. So you'll put in the Tellor address. Here's the one for Rinkeby. And it'll deploy your contract. And right now we're sample using Tellor, which we're gonna have to change with the right functions. But we're not actually deploying it to Rinkeby. So what we're gonna wanna do is we're gonna wanna uncomment out all of these things. Because all of these things, if you see there's all of these Tellor libraries, you're gonna be like, what on earth is this? And this is our sample Tellor. So whenever you're testing your contracts, you probably don't want to figure out and deploy the entire Tellor system. You would have to run a bunch of miners, and you would have to figure out how to start up all the IDs and make sure that prices are getting placed in them. For testing purposes, you just want to be able to say, hey, this is the value on the Tellor system, and we'll pretend that there's a Tellor system there. So we wrote for you guys a mock Tellor system that you guys get to use. Has all of the features of Tellor. You can practice some disputes. You can see how your whole system functions on different Tellor pieces, but there's not that whole live mining. You need a network. You can do everything locally. So first thing, of course, I changed the name from sample using Tellor to Unitize. So we're going to have to change that in 3 places. And then here, so 1, this is the Tellor ID. So this would be like ETH US dollar if you're on mainnet. But we're not on mainnet, so you can just pretend 1 is whatever you want it to be. And then it'll grab the Tellor master address that it wants. So before we migrate, we're going to have to kick off our development. So in Truffle, every time you do Truffle init, this part's commented out. I don't know why. It makes it harder to run Ganache. So you got to come in here and uncomment that piece out. But we'll go to another server, start Ganache. Ganache is, this is a pretend Ethereum network on my local computer, on my local host. Then we'll come over to this piece and we'll run Truffle migrate. Hopefully I'm making sense. Definitely tell me to slow down or do something if I'm not. So, all right, compiled. That's always good. What? It's a timeout. Did I not save this? Man, I really hope I... If this doesn't work, we're just going to have to pretend and I'm going to have to write you guys the tests. It's always dangerous doing live software demos. Okay, there we go. It's migrating. It flashes behind the screen, it deployed. See, it cost you 0.15 ETH to deploy the Tellor system and our little contract. So cool. And now, so kind of the most important part of like any Solidity development is going to be testing it. Because testing these things is awful. So we tried to fix that for you guys. We wrote you guys some tests and we want to teach you guys how to actually use it. So we'll just come in here. This was right here in the GitHub. And we'll come over and we're going to go to our tests and we're going to bring up a new file and we're going to write Unitize tests.js. Okay, so first we are not sample using Tellor, so we're just gonna do Control H, sample using Tellor. We'll change that to Unitize. Replace all. Okay, these guys got to be underscore. Yeah, this is JavaScript testing in the Truffle framework. If you guys aren't familiar with it, it's probably I like it, much easier than like the Solidity testing in the Truffle framework. But anyway, what it's going to do, basically first you're going to import the contracts that you need. And then here's the before each. So this is just deploying the contracts for each test, and it'll run this test as far as update price, but we actually don't need that one. We're going to we'll cut and paste it just to get some things down here. But the way we'll write it completely from scratch and then delete that one. So what's our function? We're going to run check values test. So check value test. The first thing that you're going to want to do, it'll deploy it. So before each, it's going to deploy it with ID 1 and a new Tellor master. This thing right here, this submit mining solution, this is going to create a new Tellor solution. So it pretends like there's 5 different miners that submit a solution, and then a new value is mined on the Tellor system. So they're submitting it for ID 1, and this is what they're saying that the value is. So 1200. So let's, we can change this. We can, let's say it's 5,000. They're all going to say it's 5,000. Now we have something to read. And then what we're going to do is we're going to run check values. So we're going to do let my result equal unitize check. Can I name it? Check values. Check values. Okay. Await. Gotta make sure you await. Okay, and then the cool thing, so this will return like the whole transaction IDs because it's not a call function, but if you do .call, now you'll get the piece that comes back, the bool. Because if you don't put that .call, it'll just give you like the whole transaction hash. You have to parse it and everything, which is, you don't want to do. So what we're going to do is assert. And what are we going to assert? We're going to assert that my result is true. So all should be true. Because if you remember, we check if it's greater than 100, and we're inputting the value 5,000. So it should be true. Hopefully you're following with that. Anyway, so now we'll bring up our node and our console, and then we'll just run a full test. Oh, wait, let me comment out this thing, because I didn't build this for this specific test, so I'd rather just not see if it breaks. Let's see, is it humming along? Yep. All right. So we're moving. Unitize.checkValues is not a function. What? Of course it is. Guessing if I take this off, will that work? Does it want me to write methods? It might want me to write methods. Yeah. So, okay. So what this is going to do, check values. Because what we can do is we can print. So wait, that's the current value. Show you guys. I know this is, and then you're just going to spend the next day trying to figure out how to get your test working. This is solidity development in a nutshell right here, guys. Man, I swear I had it working. So anyway, I'd have to Might have to talk with Ronan here about what's up with this. So I'm going to get this working, and I will post the working version in the code for you guys. But anyway, we've been doing this for a while, so I'm not going to force you guys to sit here and listen to me try and debug this, which is going to be a simple solution. So winner to whoever posts the solution first in the chat room while I figure this out. But anyway, thanks everyone for listening. You know, happy to help anybody build on Tellor, and happy to, you know, talk with you. I think one of the biggest pieces about actually using an Oracle is going to be, do you need an Oracle? Do you need it to be trustless? And what sort of guarantees do you want in there? And just working out kind of that problem statement, because that's going to be one of the biggest pieces of your DApp, especially if you're building anything on DeFi. So just over a half hour. Thanks everyone for listening. And yeah, talk to you guys soon. Bye.
Thank you, Nick. I'm sure someone will find the typo in the code. For those of you that are just joining us now, if you have any questions during the talks, please feel free to ask them in chat. Our speakers will get to them for sure. For our last session of the day, we are happy to bring you a discussion between two founders. Sam Williams, co-founder of Arweave, will join Nate Geier, CEO at Mintbase, in a discussion moderated by Matthew Farrick, whom is the head of the communications at Cent. The discussion will be about NFT and distributed storage. Recently, Mintbase was integrated to Arweave, which allows for metadata of NFTs to be stored on Arweave, fully decentralizing the process. Please take it from here, Matthew.
Hi, everybody. I'm Sparrow. Today I have Nate Geier and Sam Williams, founder of Mintbase and Arweave.
Hi.
Really happy to speak to both of these guys today because I'm a creator tokenizing my art on the blockchain through Mintbase, which is now using Arweave. So really keen to hear what these guys have to say and to tell me, specifically as a creator of NFTs, why these technologies are important. So first off, I'll let you guys introduce yourselves. Sam, do you want to go first?
Sure. So I'm Sam, one of the founders of the Arweave protocol, which is essentially a permanent information storage system. So it's the first storage system that is backed by an endowment structure, which allows you to essentially create economically sustainable storage of information forever, which has taken off a lot in the NFT space recently, because of course we have these assets that we want to make sure So we tokenize the assets first, and then we want to make sure that those assets are around for a very long period of time, so that the tokens themselves maintain their value. Yeah, and I guess this is kind of our component of this puzzle.
Yep.
Cool.
I'm Nate, the founders of Mintbase. So this is the platform that basically allows folks like Sparrow to come on board in a visual way to mint a token. They can come on our site, basically deploy their own smart contract, mint ERC-721 NFT tokens on that contract, and all of that metadata that gets bound to that token basically goes over to Arweave and gets stored. So each one of these tokens doesn't need to just hold one image, it can hold multiple files. It could hold maybe a platform enables music, or maybe a platform enables Vox files. All the platforms get to decide what these assets do. Maybe they play music on their crypto voxel land because they're the owner of this NFT. And so we basically made a massive decision about a month ago to move all of that storage from Google S3 over to Arweave. And now it's working. So basically, if Mintbase dies tomorrow, as long as Ethereum and Arweave are still alive, those tokens can live on.
Very, very cool. Right. So before we deep dive into some questions, because you brought up some really interesting topics there, can you both tell everyone a little bit about how you got into providing the solutions that you're providing, how you got into blockchain, and why you chose to do this specific project? So Nate first.
Sure. Yeah. I worked pretty deep in the fintech land with clearing firms, which basically says you have 5 shares of stock because we say you do, and broker dealers, which is the intermediary between the customer and it's a long drawn out story, but I really got to see how complicated the financial system is. When you throw all those away and get to interact directly with the settlement layer, Ethereum, which is the thing that you can move value from A to B very securely without a single company in between. That's what really got me interested. And yep, shoot for it, Sam.
Cool. Yep.
Yeah, we started from a slightly different position, but ended up building something very general, and then realizing that that general thing could be applied to lots of stuff. So we got into this realizing that you can use blockchains to make decentralized data storage that is immutable. Except the problem was that blockchains basically just didn't scale to fit the amount of data that we needed inside. And they also didn't have sustainable economics to back that storage. So they had kind of half of it, like the technical side of how do you coordinate computers across the world to replicate a piece of data, but not the economic side that says how do you actually then incentivize the humans to store that data for long periods of time. Yeah, and what we wanted to do with this originally was make an archive of news articles and other kind of records of history, because we realized that that's really valuable stuff that now in the blockchain era we can make sure can never be lost. But then once we solved that problem, we realized that actually this is way more applicable to really just kind of, yeah, everything from NFTs to storing web applications, storing web pages, PDF documents, like whatever it happens to be. It's very generally applicable, and that's kind of how we got here, I guess.
Fantastic. Okay, so let's deep dive into Arweave a little bit. Can you just explain? I mean, I'm familiar with IPFS. I think most people are familiar with IPFS. Can you tell us what makes Arweave different to IPFS?
Yeah, sure. So IPFS is a content distribution network. The idea is that you put a piece of information into IPFS that you pin on a machine somewhere. And so you have like a centralized server that is hosting the file essentially, and then it can be cached around the world, and it has the same address. And then you can go IPFS : hash, and you can get it from some server somewhere that is caching it, or the original place that uploaded in the original server that uploaded in the first place. That's great, but it's a content distribution network. It's not really a storage layer, which is, I think, kind of a misunderstanding in the crypto space. Arweave is a storage layer, and it's focused specifically on this endowment-backed permanent storage, where you pay once and you just replicate a piece of information forever. Does that kind of answer your question?
It does. It does raise the question about this endowment mechanism. Can you give us sort
Yeah,
of
for sure.
what's that all about? How does that work?
Yeah, it's a claim that seems like it shouldn't be reasonable up front, but then you kind of get into it and it makes sense. And so what we do is when you put a piece of information into Arweave, we pay for the storage of that information for 200 years, which sounds like a lot. It turns out storage is so cheap, it's actually like approximately ½ cent per megabyte. And then over time, the cost of storage declines. And so you've already put across this capital, you've already put up this capital, and you essentially gain interest in the form of storage purchasing power on that capital you've already put aside over time. And so as long as the cost of storage declines at a greater rate than 0.5% on average every year, then you essentially just continue accruing interest on this capital that you already put aside. So increasing the storage purchasing power of your endowment contribution rather than decreasing it over time. So we looked back at the history of data density and data reliability over the last like 50 years. And on average, the decrease is at a rate of around 30.5% per year. So our estimation of it is extremely conservative. Then on top of that, you look back like further, and you see that actually we didn't do it inside computers before that, but we were essentially trying to store data in more and more dense formats. And you see that the exponential decay is essentially consistent across like thousands of years. And then the question becomes, well, okay, just because it happened in the past doesn't mean it's going to happen in the future, right? So we looked at where we are in terms of the currently deployed technology versus what the theoretical limits should be. Like, what is the most data dense thing you can ever create? And so where we are in terms of data density is 1 × 10⁻13 bits per cubic centimeter, relative to 1 × 10⁻, approximately 70 bits per cubic centimeter, which is the theoretical maximum data density limit. And so if you were to continue towards that at the current average rate of 30.5% per year, it would take you 434 years, or rather it was 434 when we calculated this. That was a year ago though. So it's 433 years approximately. Yeah, to reach that maximum point. And then the final part of this.
Go ahead. The final part, hit it.
Yeah, the final part of this argumentation is to say, okay, well, fine. So it looks like it's possible for a very, very long period of time. And you know, if you put the data in now and you get 30% interest per year for at least 430 years, then that ends up being like tens of thousands, hundreds of thousands of years. Yeah. Okay, so it's possible, right? Exactly, it's possible. But the question is it? Will we definitely do it? Like, is the incentive there in human society? And we think that because everything in the economy is essentially heading towards information storage and manipulation as the jobs, as the economy itself. People's jobs now, they go to work and they take information and they turn it into more information. Data storage will continue to be at the core of that, change in society for an extremely long period of time to come. So that's why we think you can actually have data permanence.
And our big selling point for Mintbase was the file discovery. So like you said in your video that it could take up to 7 seconds to find your files within IPFS.
7 minutes. Actually.
7 minutes, that's right. So a big difference.
Yeah.
A website can't run like that. You can't download a page with 30 different NFTs with 5 different data points for each NFT and have it take up to 7 minutes for every single data piece to come together to load a page. So what people end up doing is they basically take all that information and then put it on their own private server as a redundancy and then serve the files that way. So that's kind of a duplication and unnecessary in my book. But the other idea is that you can have companies like Pinata solve this problem as well. And so then you're basically just punting to another centralized system to basically solve all your problems. The endowment mechanism basically decentralizes those 2 points. And so the other big issue too is that on IPFS, data can disappear, just like how Napster works way back in the day. If someone decided they don't like the Britney Spears song from way back in the day and no one pings it enough, then that file just goes away. If enough computers that are hosting those files decide Britney Spears isn't cool, and those computers go offline, then that file gets completely lost. So those 2 points, working with the decentralized endowment mechanism was our big, like, aha, this makes sense.
Yeah, I think that was actually one of the misconceptions that a lot of people I came in touch with had, that they believed that once something was on IPFS, that it was stored there forever. But you're right, it has to have been used to incentivize it to be cached and kept. So that's interesting and an important point, I think.
There's this difference between permanent addressing and persistence of data, which I don't think, frankly, the IPFS like marketing really, addressed.
Yep.
We also like IPFS. Like CDNs are great. You need them. We need them on top of our network. You can access everything inside Arweave if you put a special tag on it. Also inside IPFS. Like it's a really valuable thing to have. It's just wasn't quite what, in some senses, it was advertised as.
Yeah, we're using it heavily with our entire backend runs off of the graph, and the graph basically indexes all Ethereum data to IPFS, and then our interface updates based on that data. I mean, it has an immutable data structure, which is extremely valuable as long as it doesn't go away. So, and what we love about Arweave too is you have immutability and you have timestamps. Oh, did we lose you, Sparrow?
Nope, I'm still here.
Cool.
My video just stopped, but that's.
Oh, there we go. We're back. Cool.
Right. So I was going to ask you, Nate, because I'd asked Sam what made Arweave unique. What makes Mintbase different to the other NFT minting platforms?
Yeah, so my big point is I feel like everyone should not just use one NFT minting platform as their go-to. I see a lot of artists and minters not just going to one platform they use a lot. My suggestion is everyone should use all of them, play around with them, see how they all work. The most important thing is we're all very small. Find a founder that has the same ideals as you, and then we'll grow with you. So our platform isn't perfect. Nobody's platform is perfect. Blockchain is not perfect. It's all, it's early days and things break. But we're different in that.
It's a big experiment. Yeah.
Yeah, we're going to experiment with you. We want you to come to Mintbase and create a news agency, add minters as press people, create a DAO Records label, and add minters as music artists. It's going to be a very strange world, and we want to grow with those folks that kind of want to say, okay, here's this decentralized asset that we can put on any wallet. What can we do with that? And yep, that's our focus. And it's sleek looking. It's pretty. If I do say so myself.
It is one of the prettiest places, yeah.
It is, yeah. But that's actually really important because one of the problems we've traditionally had in the blockchain space is that everything looks like it was built for hackers. It's just really, really basic. The user experience just isn't there. And Mintbase is a pretty big step forward in that regard. So that's neat.
Dankeschön.
Yeah, and certainly with utility tokens and things like that, I think that's only going to grow, and that needs that ease of use. And like we were talking about a little bit previously, that being able to sort of plug things together to provide the functionality that you want, which is kind of the way I see, what you're doing with Mintbase. You've plugged into the graph to get that bit because that's best in breed. You've now plugged into Arweave because that's best in breed. To provide the exact service that's required, and that can only expand, I think.
Yeah, and to that note, I feel like I support a lot of the other platforms. I love Super Rare. I love them all. They're all doing it the right way, the hardest way that we can. It's when we start building on centralized platforms that basically punt a lot of like the hard stuff back into stuff we've already done before. So when you're using a platform and it asks which wallet you want and it supports a whole lot of wallets, then that's probably a good platform to start with.
Yeah, yeah. So a bit off scripted, you know, there are some platforms that are trying to mask that blockchain layer, right? So they don't even want to ask for a wallet. Do you have an opinion on that? What do you guys think about sort of hiding all this tech from like artists like me?
I have one thing to say. Okay, so it's like Google Glass versus like the big old binoculars for like Oculus or something, right? Google Glass tried to like jump the shark and make them sweet looking glasses, and you were gonna do all your things on it. In reality, it was too quick, too early, too soon. So if someone's hiding all of that, you're gonna get a crappy experience, and it's just not gonna get the real deal. But right now, I feel like we need to solve it the right way, the hard way, and make people jump through the hoops to understand what they're doing. And then we'll slowly get that Google Glass experience maybe over time.
Cool.
Yeah,
Sam,
I mean, okay, so if we can make the Google Glass actually decentralized, then that's great. But that's going to take a lot more time. There are some solutions, though, right now that I think could be like, they're kind of like blockchain light, you could call it, right? So it's like, it has some of the attributes that a blockchain has, but you don't necessarily completely own your identity, which really isn't great from a value add perspective, but also it does allow people to get into the ecosystem much, much faster. I think that is something that it's almost like try before you buy kind of thing, right? So you can like test it out with the free version, and then when you realize that it's cool, you just upgrade to this slightly more complex version when you actually own your identity. Until we get the properly decentralized Google Glass, that's probably the best it's going to be for now. And like we do this with Arweave, we say, you can come to us and you can get like a wallet with, used to be 5 Arweave tokens, used to be an Arweave token, and now like, because people try and steal these tokens so much, we've had to change it to like 0.25 tokens. But you can come to us and you can get a very, very small amount of R so that you can use the system in like a pre-filled wallet. Yeah. And it's kind of like the easy onboard to the network. But then when you want to use it properly, you want to make your own wallet and you want to like store it inside the web extension or something like this. I think we have to be sort of practical about these things while also not losing sight of why it was important in the first place.
Yeah, so your wallet's like going to Rinkeby and getting fake ETH to play around with a little bit and try it out there before you actually buy your real investment.
Yeah, or just get your like in this sense, real identity on the firm web.
Okay, so yeah,
I have a question.
This has been a great discussion.
When is it going to get listed on Coinbase? Is that coming soon?
I can't talk about that.
Okay, so
but it's now traded on like 8 or 9 different exchanges if you want to go there and buy or sell it.
Yeah, sorry, Sparrow.
1 minute to wrap up with each of you. Sam, do you see Arweave competing with cloud services like Google and Amazon anytime soon or in the long term? Do you feel that this is the model that all cloud services will move to?
I don't think that the focus in decentralization should necessarily be on competing with existing services. I think that the focus should probably be on allowing people to do things that they couldn't do before, like NFTs, or in our case, permanent storage of information, like literally permanent storage of information, which no centralized party could ever really sell to you because they have centralized ownership and management, and they're eventually going to change their offerings. So I think what protocols do really well is they allow you to they enable certain types of business models that weren't possible before. And that's at least where I see the interest.
That's really exciting. Yeah. So Nate, NFTs in the future, what's your take? What's Mintbase going to be in 10 years' time?
Whole theory of one blockchain winning them all, it's not going to be it. It's there's going to be multiple different blockchains all interacting and working together, doing this, that, and the other. And yeah, that's the future. So I'm pretty excited to experiment and play around.
Very cool. Thank you both for a really interesting conversation. I've learned a lot, so thanks.
Thanks for moderating.
Thank you.
Cheers.
All right.
Thank you, Nate, Sam, and Matthew for the insightful discussion. That's all the content we have for everyone on the Developers Track. On behalf of Unitize, I want to thank everyone for tuning in and becoming more educated on how to build in crypto. I want to encourage everyone again to please check out the Unitize virtual hackathon. There are numerous prizes involved. Please stay safe out there and enjoy the rest of Unitize.